Example 6, find an equation of the tangent line to the curve y is equal to e to the x divided by the quantity 1 plus x squared. Okay, so we're going to take a look at the function. We know the function is y, which is equal to e to the x divided by 1 plus x squared. Okay, and we're going to let f represent the numerator function, and we're going to let g represent the denominator function. Now again, over here to your right, when we have our quotient rule, we can say that g times f prime minus f times g prime over g squared, or the best way to remember it is low d high minus high d low over low squared. So what we want to do is we want to find y prime. Now remember that y prime is the same thing as dy over dx. Okay, so what we want to do is we're going to find the low. Well, the low represents the function g. So g represents 1 plus x squared. So we have 1 plus x squared. And then we're going to multiply that by the derivative with respect to x of the function f, which is e to the x. And then it's going to be minus. Now we're going to take the numerator, which is the high part, which is f, and f is e to the x. And we're going to multiply that by the derivative with respect to x of the low, which is 1 plus x squared. And then we're going to divide that by the denominator, which is the low, and we're going to square it. So it's going to be parentheses 1 plus x squared squared. Okay, let's continue. So we want to find the derivative of e to the x. So we know that from our rule, the derivative of e to the x is e to the x minus e to the x times, well, what's the derivative of 1? Well, it's 0. And the derivative of x squared is 2x. And then we're going to divide that by 1 plus x squared squared. Okay, now let's go ahead and distribute here. So we end up getting e to the x plus e to the x squared minus 2x e to the x all over 1 plus x squared squared. So now we know that we have an e to the x that we can factor out. When we factor out, we end up with 1 plus x squared minus 2x divided by 1 plus x squared squared. Okay, now just doing a few different extra steps, we should see that what's in parentheses represents a trinomial, which is a perfect trinomial that we can actually factor. So now let's factor that numerator. So the trinomial in the numerator is a perfect square trinomial, like we said. So therefore, that's going to be x minus 1 squared all over 1 plus x squared squared. So again, this is the derivative where it's y prime, which is equal to dy over dx. So therefore, this is the derivative, and we know that this represents the slope. So recall that at the beginning, we know that its tangent line is at the point 1/1/2 e. So we can say the slope of the tangent line at 1 and then 1/2 e. So we're going to use the fact that x is going to equal 1, and then we're going to plug it into the derivative function. So we're going to write e to the 1 times 1 minus 1 squared all over 1 plus 1 squared squared. Well, then that gives us e times 0 over 4, which then means that the slope is 0. So we can then say that m is equal to 0. Okay? So now we want to find the line that is tangent. So what we're going to do now in step number 3 is we're going to use the point slope form. Y minus y1 equals m times x minus x1, where we know that the point is 1 and then 1/2 e, and the slope is 0. So we have y minus 1/2 e, which is equal to 0 times x minus 1. Well, that means we get y minus 1/2 e, which is equal to 0. And therefore, y is going to equal 1/2 e. So what this means is that the tangent line at the point 1/1/2 e is horizontal, and its equation is y is equal to 1/2 e. So now let's graph the function and the line that is tangent to that function. So we know the function is e to the x, and that's divided by 1 plus x squared. Okay, now remember, it passes through the point at 1 and then 1/2 e. Okay, and then let's go ahead and graph that, which is, we know that the line is y equals 1/2 e. So if we write y is equal to 1/2 e, and therefore there is our graph. So let's take a look at this graph, and so we can say that the function, you can see that the function is increasing and crosses the tangent line at the point 1 and then 1/2 e, which is that point right there. So again, this graph represents y, which is equal to e to the x over 1 plus x squared. We also know that this graph is y is equal to 1/2 e. And again, it crosses the point where you have 1 and then 1/2 e.